All right. Today we are going to talk about dividing rational expressions. And it's very, very similar to multiplying. Okay, so if you were comfortable with multiplying, this should be a piece of cake. If you were not comfortable with the multiplying, this will just be more practice to get you comfortable with both of these. Okay, so these are very, very closely related. There's just one, well, actually, I guess two small differences that we're going to touch on today. So first, we need to make sure that we remember how to just divide normal fractions before we get into dividing rational expressions. So this first problem, we have 2/3 divided by 1/4. How do I do something like that? So multiplying is straight across. So if this were 2/3 times 1/4, I would just multiply the numerators, multiply the denominators. But if I'm dividing fractions, what do I do? Abby? We have to flip second fraction. Right? So 2/3 divided by 1/4 is the same thing as 2/3 times 4/1. Okay? 2/3 divided by 1/4 is the same as 2/3 times 4/1. Okay, so now we can just multiply straight across. So 2 times 4 is 8, 3 times 1 is 3. 2/3 divided by 1/4 is 8/3. Right. How about the second one? Here we've got a couple of variables. What would I do for this one? Bless you. No. That's it. That's the answer right there. Not quite. So it's same idea. Right? I want to bring my first fraction down. So 2x over 3. And I'm going to multiply by the reciprocal. So 3y over 5. What's a reciprocal? Reciprocal just means flip the fraction. So numerator becomes denominator, denominator becomes numerator. So now I can just multiply straight across. So 2x times 3y, what would that be?
6y squared. No,
so that, yeah, they're different variables.
Yeah, I just not see that.
No, you're good. So the 6 part's right? So how do I multiply x times y? What would I write? Yeah, just xy, right? So this will just be 6xy over 15. Now, we could make this a little bit better, actually. Okay? I could actually reduce this. I can think about 6 over 15 as a fraction. And I just want to reduce that fraction. So that would be
3xy.
2 over 5, yeah. So if I divide each of these by 3,
Oh, okay.
6 divided by 3 is 2. 15 divided by 3 is 5. So I could make this 2xy over 5.
Wait, did I say 3?
You said 3.
Okay, yeah.
Alright, so let's take a look at the last one here then. Okay, this one we throw in a few more expressions. So,
Thank you.
thank you.
Was that a cough?
It was a cough.
Okay, well, still bless you.
Thank you. So again, I'm multiplying by the reciprocal. Okay, so by the reciprocal of the second fraction. Okay, the first fraction stays exactly the same. The second fraction, I flip it. So how can I multiply this now?
Don't those cancel out?
Yep. This 2x plus 1 and this 2x plus 1 will cancel out. Right? Because one's in the numerator, one's in the denominator. So I'm just left with 7 over 3y. Alright, now, one thing that we want to obviously continue doing is stating our restrictions. Okay? So this is going to be the second thing that's slightly different between dividing and multiplying. Okay, when we were multiplying rational expressions, we just said take every factor in the denominator and figure out what value of that variable would make that factor equal to 0, and those are our restrictions, right? When we're dividing, notice we had some other denominators in certain places, right? Here in the original problem, the 7 was the denominator, but when I flip the fraction, the 2x plus 1 becomes the denominator, right? So on this problem, we want to circle any factor that was ever in the denominator, okay? Not just in the denominator in this step, or not just in the denominator in my original problem. Any factor that was ever in a denominator.
So before you even flipped it. So before and after you flipped it. So that 7 would be
Exactly. Before and after we flipped it. So I'm going to look, I've got this 3y and the 7 up here in my original problem. And then after I flip it, I've got the 3y and the 2x plus 1. Okay? Factors that were ever in the denominator. That's how I'm going to get my restrictions. So here, okay, I'm thinking, well, what value of y would make this factor equal to 0? I've got 3 times y. What's that?
negative
3 times negative 3 is not 0.
0.
0. Right? Whenever we have a variable that's either by itself or just being multiplied by some number, 0 would be the excluded value. So here we say y cannot equal 0. What about this 7? Does that give me an excluded value? Should it be like negative 7 or something? Why not? There's no variable, right? I can't plug in a number here because there's no variable. So if there's no variable, that is not going to give me an excluded value. How about this 2x plus 1? Not 0.
Negative.
It will be negative 1/2. How'd you get negative 1/2?
Lucky guess.
So what if it's not immediately obvious, what we can do is take that factor and say that factor cannot equal 0. Right? So 2x plus 1 cannot equal 0. And then we solve for x. So I get 2x cannot equal negative 1/2. Divide by 2, we get x cannot equal negative 1/2. Okay, so on this, we had 2 restrictions. Okay, the key, okay, and we'll obviously go through some more full examples here, but the key for restrictions on division is making sure that we're looking at every factor that was ever in a denominator. Okay, every factor that was ever in a denominator. Questions so far?
Actually, help me. I forget how you get 3y. And then y equals, or y cannot equal 0.
So it's the same idea as this. If I take that factor and say 3y cannot equal 0, I just want to solve for y. So to do that, here I would just divide by 3. 0 divided by 3 is still 0. Any other questions? All right. Then let's take a look at an actual example here. All right, so what should go in the blank here? When dividing rational expressions, multiply by the reciprocal. Okay. And I guess we should make sure that we understand only of the second fraction. Right? We're not flipping both of them. We're only flipping the second one. Okay? We're only taking the reciprocal of the second rational expression. Factor each of them, and then simplify. Okay, so the first step, okay, I'm just going to rewrite this as x minus 3 over 2x squared plus 9x minus 5 times the reciprocal. So times 2x minus 1 times x minus 7 over 6x minus 18. Okay? First step, when we're dividing, should always be to just rewrite it as a multiplication problem and flip the second fraction. Now, this becomes a problem just like what we've been doing. Right? Now, I just want to factor everything I possibly can and cancel out factors. Right? So, can I do anything with this x minus 3? No, right? There's no squared on it. I can't factor out of GCF. That's it. How about the 2x squared plus 9x minus 5?
X factor.
I can x factor that. Right, so I'll come off to the side here and x factor. So 2 times negative 5 is negative 10 and 9. So I want two numbers that multiply to negative 10 that add to positive 9. It's disgusting. It's going to be 10 and 1.
It's going to be -10. Or no, never mind.
Negative 1. Because 10 plus negative 1 would be
Oh, I was
positive
looking at
9.
that top number. Never mind.
Yeah. So now, are my factors x plus 10 and x minus 1? Why aren't they?
I don't know. You just gave me the
Wait, what?
So I cannot go straight to factors on this problem. Okay, my factors are not just x plus 10 and x minus 1 because my leading coefficient here was not 1. So I have to factor by grouping. And so the way we do that,
2x squared plus 10 and x minus 1.
okay, I'm just splitting up that plus 9x into plus 10x minus 1x. Right? So now we group the first two, group the second two. What GCF can I take out of the first pair?
2x
2x. What am I left with?
plus
X plus 5. What GCF can I take out of the second pair? Negative 1. Exactly. And then I would also be left with x plus 5. So what's my final factored version here?
2x minus 1 and x plus 5.
Exactly. All right, so I can replace this 2x squared plus 9x minus 5 with 2x minus 1 times x plus 5. Now, this was actually already factored for me, right? The numerator in my second fraction here, so I'll leave that as 2x minus 1 times x minus 7. What about my denominator here? Can I do anything with 6x minus 18?
Yes.
What can I do?
You can take out a 6, and it would be x minus 3.
Exactly. I can take out a 6, and I would just be left with x minus 3. Now what?
Now you start canceling stuff out.
Now we can start canceling stuff out. So, let's see, I've got an x minus 3 and an x minus 3. Those will cancel.
X, or 2x minus 1.
Yep, and those 2x minus 1s. So, let's see what we're left with. We're left with x minus 7 over 6 times x plus 5. So that is my final factored version. Now, we need to find our restrictions. So remember, that means any factor that was ever in a denominator. Okay, so to do that, okay, we want to look at all of our denominators here. So in our first fraction, the denominator never changes. Right? We keep the same denominator. So I want to look at my factored form of that denominator. Right? That's going to get me my restrictions over here. In my second fraction, I did flip the denominator though. Right? So I want to look at this denominator and this denominator. But this denominator is the same as this one. Right? So I can just look at my factored version. Okay. Now it's okay if we take a look at both of these and we see we end up with the same excluded value. Okay, we would only have to write it once. But if we take a look at each of these, right, each of these denominators, I guess let's start over here. 2x minus 1. What value of x make that factor equal 0 on half. Okay? And again, if you can't see that immediately, right, just come off to the side and say 2x minus 1 cannot equal 0, and solve that little equation. So we would add 1, add 1, 2x cannot equal 1, divide by 2, x cannot equal a half. Okay. How about x plus 5?
X cannot equal negative.
Right, x cannot be negative 5. Alright, so then I'll come back up. Oh yeah, we can do that one first. So this one would be x cannot equal 3. And then we want to come back up here. So this factor was the exact same, right? So I already have x can't equal a half. How about this one?
X can't equal 7.
X can't equal 7. Okay. So just two small differences between multiplying and dividing. Okay, when we're dividing, the first step is just to flip the second fraction. Then it becomes a multiplication problem. And the other small difference is when we are writing our restrictions, we need to look at anything that was ever in a denominator. Okay? Questions? Do we want to do another one together? All right, let's do another one together. All right, so here we've got x squared plus 2x minus 15 over x squared minus 16 divided by x plus 1 over 3x minus 12. What's my first step?
X back.
No, flip
Flip the second one.
Yeah.
My first step is change it to a multiplication problem. Right? So the first fraction stays the same, and I multiply by the reciprocal of the second. Now, we want to factor everything we can. So let's start up here, x squared plus 2x minus 15. I want to x factor that. So 1 times negative 15 and 2. So I want two numbers that multiply to negative 15 that add to positive 2. Negative 3 and 5. Are those my factors, or do I have to factor by grouping? Those are the factors, right? Because my leading coefficient is 1. So I don't have to do anything else. My factors are just x minus 3 and x plus 5. How about my denominator here, x squared minus 16? What can I do with that? Can I take out a GCF? No GCF. This is a difference of squares, right? So how would this factor? X plus 4 and x minus 4. Alright, so how about over here? I've got 3x minus 12 in my numerator. What can I do with that?
Wait, you so much more?
The 3x minus 12.
You could do 3.
Yeah, I can take out a
Parentheses
GCF.
x minus 4.
Yep, exactly. I'll be left with x minus 4. How about the x plus 1? Can I do anything with that?
No.
Nope. So that will stay as x plus 1. Now what?
Start canceling.
Start canceling. So I think I only see one thing that we can cancel. Right, the x minus 4s. So we would still be left then with 3 times x minus 3 times x plus 5 over x plus 4 times x plus 1. So now we need our restrictions. So we want to look for anything that was ever in a denominator. So again, on my first rational expression, the denominator never changes. So I can just go all the way down to here and look at my factored form. Over here, though, my denominator did change. So I need to look at the denominator before I flipped it the denominator after I flipped it. Okay? These will be where my restrictions come from. So, what restriction would I get from this factor? X cannot be negative 4. And this one would be faux. How about this one? The 3x minus 12. How'd you get that? Well, so remember, what we want to do is think about setting that whole factor as it cannot equal 0 like that, and solving. So, I would add 12, add 12, we get 3x cannot equal 12, divide by 3, and x cannot equal 4. We already had that one, right? So, this one we have. How about this one? X cannot be negative 1. Okay? So, we flipped our fraction, factored everything. We were only able to cancel out one pair of factors here, and then got our excluded values from anything that was ever in the denominator. Questions? All right. Why don't you guys try example 2 here?
Yes.
Well, seeing as how this is a government institution, yes.
We're in a government institution.
Yes, technically.
Institution.
Yeah.
Do I take my job?
What?
I know the kids laughing. Who's Brenda?
Babysitting.
You didn't even get to
I think I seen it. She was in there by her.
Spreading the butter.
Oh, wait, Mr.
Yes, ma'am.
Don't listen to him.
You want to know what we really need?
Don't
Like,
listen to him.
one of those like little
Plus,
clipboards for like when you do like the cut
Second
for the
time
movies.
listening to
They're
him,
like
my whole
marker.
Yeah.
I won't.
And then I said, dude, why would you tell me to do that? If you knew it would work. He said, I don't know why you listen to me.
Because you're the teacher. What do you want from me? Marker. Action. I'm just.
That's what. I'm smothering.
All right, did we get 7x minus 5 over 5 times 3x plus 2? Then we would end up with a bunch of excluded values here. Okay, remember we have to look at everything that was ever in a denominator. So we just go factor by factor. Say, well, if I set this 3x plus 2 equal to 0 and solve, I would get x cannot be negative 2/3. This one, I would get x cannot be 2. This one, I would also get x cannot be 2, so I don't have to write it again. Okay, I already have 2 there. Here, if I set this one equal to 0, I would get that x cannot be 5 over 7. And then this one, I get x cannot be 4. Okay. So any factor that was ever in the denominator is how we get our restrictions. Questions? Feeling all right with this? All right, go ahead and try the next one. Does what?
The institution.
All right, did we get something like this? 2 times 3x minus 10 over 5x plus 3?
Oh, like this.
Why not?
I don't know. I think it's hard. I get confused.
Where do you get confused?
It's not hard. It's just a lot.
It is a lot.
Like,
Yeah.
what's with the X? Is that?
The X factor?
Yeah.
Oh, X factor is easy. I love X
So
factor.
what's tripping you up?
It's always tripped me up since like sophomore year. Like,
Where? What parts? I mean, do you have trouble getting these numbers
Yes.
or doing the X, like factor by grouping or
I'm
what?
not a factor by grouping. I have trouble like finding like the
You need a new
Okay.
marker.
Yeah. So the easiest way to do that is just start listing out the factors of 30, right? So like 1 times 30, 2 times 15, 3 times 10, until we find a pair that we think might add or subtract to this number down here. So I mean, on a lot of the problems I've been doing, I have not been writing these out. But I mean, if you're so working on finding those numbers, I mean, just write those out until you find one that looks like it's going to work.
Are we going to have a test eventually over everything we learned?
Whoa.
Yes.
We never have it.
It seems like we only had one test.
I don't want to bully you.
We haven't had a test in a while.
Good.
We didn't have a test over the sequences and series stuff because that was just part of the midterm.
That was hard.
So it has been a little while since we've had a test. All right, any questions on this one? All right, we've got one final example on there, I believe. All right, so on this one, what's my first step?
You gotta flip.
Gotta flip it. So the first one stays the same. That multiplied by the reciprocal of the second one. Now what?
You simplify.
Now we simplify, right? So we want to factor everything we see. So this is 9x squared minus 49. Can I take out a GCF?
I don't think so,
I don't think so either.
because I just tried it.
Yeah, I don't think 9 and 49.
The only thing that goes into 49, the highest thing that goes into 49 is 7.
Right. Is there anything else I can do to simplify 9x squared minus 49?
No. Is there? Is that a trick question?
It's not a trick question, but there is something that we can do.
Oh, we can square it.
It's a difference of squares. So
It's
both,
going to be.
both of these are perfect squares.
Wait, is it 3? Is it going to be 3x
Uh-huh.
minus 7?
Yep.
And then 3x plus 7.
Yep.
I forgot about that.
Now, how about the denominator here? 6x squared minus x minus 15. What can I do with that? Is there a GCF? No. Okay. So, since this is a trinomial, let's see if it factors. So 6 times negative 15 would be negative 90. Right, and then negative 1. So I want two numbers that multiply to negative 90 that add to negative 1. What numbers will multiply to negative 90 and add to negative 1? So this, we've used the difference of squares to factor. Both of these are perfect squares.
9 and 10.
Yeah, we're going to use 9 and 10.
It's going to be negative 10.
Negative 10. Yep. So here, since my leading coefficient is not 1, I have to factor by grouping. So 6x squared plus 9x minus 10x minus 15. Group the first two, group the second two, less 1. I can take a 3x out of the first pair. I would be left with 2x plus 3. Then I can take a negative 5 out of the second pair. And I would be left with 2x plus 3. So my factored form is 3x minus 5 times 2x plus 3. So that I can put in my denominator here. Then everything over here is already factored for me. cancel some stuff out. See, these 3x minus 5s cancel. These 3x minus 7s. And I'm just left with 3x plus 7 times 4x minus 9 over 2x plus 3. Then we need our excluded values, and that comes from anything that was ever in the denominator. Right? So obviously these, and then this denominator before we flipped it. Okay? So tomorrow we will do practice.